Imagine this. You wake up tomorrow, unplug your phone, and it's already full. You walk to your car, plug it in, and before your coffee even cools down, the battery hits 100%. Not in hours, not even in half an hour, but in 3 short minutes. No lithium, no overheating, no fire risk, just pure, instant power. Sounds unrealistic, right? But right now, inside secret labs and giant gigafactories, engineers are building a new kind of battery. One that could charge faster than we've ever seen. One that may be safer, cheaper, lighter, and powerful enough to reshape the entire EV industry. And yes, Tesla is right in the middle of this race. So here's the real question. Is the age of lithium finally ending? And is aluminum-ion, or other next-gen chemistries, truly ready to replace it? Make sure you watch till the end, because what's coming next might change cars, factories, and global energy forever. Before we talk about the future, let's quickly understand the present. Tesla doesn't use just one battery. It uses multiple chemistries, each designed for a different job. Lithium iron phosphate, also called LFP, powers Tesla's affordable models in many markets. These batteries are stable, safer, and last a long time. They don't mind being charged to 100%, and they're great for daily driving. The downside is that they're heavier and store slightly less energy per kilogram. Then there are nickel-based batteries like NCA and NCM, used in Tesla's higher-end vehicles. These deliver more range and more punch, perfect for performance cars. But they're more expensive, and they require careful cooling. And sitting at the center of Tesla's strategy is the famous 4680 cell, a physically larger cylinder packed with energy and designed to slot directly into the car's structure. Fewer parts, lower weight, lower cost, faster production. That's the idea. So yes, Tesla has pushed lithium-ion farther than anyone expected. But lithium comes with problems. Rising costs, mining challenges, geopolitical control, and safety limits. That's why the search for the next battery era is happening right now. Lithium isn't rare, but refining it is slow, costly, and politically complicated. Most supply chains pass through a handful of countries, which means shortages and price shocks are always a risk. And then there's safety. Lithium batteries can overheat. We've all seen the headlines. So engineers began asking a simple question. What if a battery could charge faster, stay cooler, cost less, and still deliver real-world performance? That's where aluminum-ion and alternative chemistries enter the story. Aluminum is everywhere. It's lightweight, cheap, recyclable, and each aluminum atom can carry 3 electrons compared to lithium's 1. On paper, it has serious potential. In aluminum-ion batteries, energy is stored and released as aluminum ions move between electrodes, similar to lithium, but using different materials and electrolytes designed to stay stable and cool. Lab tests around the world have shown ultra-fast charging, sometimes minutes instead of hours, very low fire risk, simpler recycling, and lower potential cost. And because aluminum is abundant, the supply chain could become more stable and more global. This is why startups, research labs, and huge automakers, including Tesla, are actively exploring it. But here's the honest truth. Right now, aluminum-ion batteries are still young. Some prototypes charge incredibly fast, but energy density still needs improvement to match long-range EV lithium packs. Manufacturing must scale, supply lines must adapt, real-world testing must expand. So the future likely isn't lithium or aluminum. It may be lithium and aluminum, plus sodium-ion, solid state, and more. Different chemistries for different uses. Performance EVs for high-energy cells, affordable cars for cost-efficient chemistries, and energy storage for ultra-safe, long-life batteries. This is the battery future Tesla, and the entire industry is building toward. Right now, a silent industrial race is happening across the world. China, India, the United States, Europe, and Africa are all competing to build the cheapest, safest, scalable battery. Whoever wins this race will control the future of transportation and energy. That's why we're seeing new gigafactories, billions invested in research, aggressive cost reduction goals, and entire manufacturing lines being redesigned. Because the next battery breakthrough won't just change cars. It will change power grids, shipping, aviation, and renewable storage. Tesla has always said it's not just a car company, it's a battery and energy company. From Powerwalls to Megapacks, energy storage is a core part of its business. So exploring aluminum-ion, sodium-ion, and new lithium chemistries isn't hype. It's strategy. Lower cost, higher safety, faster charging, more supply chain control. It's how Tesla plans to reach the next billion electric vehicles. So will lithium disappear overnight? No. Lithium-ion is still improving fast. New designs are safer, cheaper, and more durable than ever. But the monopoly is ending. The future of batteries is multi-chemistry. Different tools for different jobs. And somewhere inside labs today, the battery that will power the next generation of Tesla may already exist in prototype form. We're standing on the edge of the next energy revolution. Just like steam gave way to oil, oil is now giving way to electricity. And batteries are the beating heart of it all. Whether aluminum-ion becomes the next dominant chemistry or simply one of many, one thing is certain. The companies that master batteries will shape the future of transportation. And we'll be here, breaking it down, step by step. If you love real-world technology, factory innovation, and the future of EVs, make sure to like, share, and stay tuned here on Prodexia AI, because this story has only just begun.